In this example, we are going to use the TI-83 Plus and TI-84 Plus to help us find the solution to systems of linear equations by graphing. We'll take the example of some phone cards. A communication company offers a variety of calling card options. Here we've got two. Card A has a 30-cent connection fee and costs 2 cents per minute, and card B has a 10-cent connection fee and costs 6 cents per minute. We want to find the length of the call in which both calling card options would be the same. We have to turn these facts into an equation. And so here it is. We have y is equal to 2x plus 30, and the second equation is y is equal to 6x plus 10. In both cases, x stands for the amount of time in minutes, and our units here are in cents, not dollars, which is why we don't see any decimal points anywhere. Alright, now here we're back at the calculator. We want to click on the y equals button and put in our two linear equations. The first one was 2x plus 30, and the second equation was 6x plus 10. Alright, let's see what the graph looks like. So we hit the graph button. Alright, now we notice that when we look at our screen that we only see one line. That's strange. Where's the other line? It should be there someplace. Well, it is there. It's just beyond what we can see. We're going to have to change the dimensions of the window so that we can see both lines and see where they intersect. So hit the window key on your calculator, and I am going to go down to the y min and y max. That's the most helpful. We're going to change y min from negative 10 to 0 and make y max 50. Now I chose 50 because I noticed that the y-intercept of the first equation, 2x plus 30, was 30. So we want to go a little bit more than that so we can get a good view of everything. Now the y-scale is still 1, and I'm going to change it to 10. So it will show us hash marks here on the y-axis. Each one of these represents 10. And there's our first equation, and there is our second linear equation, and we see that they intersect right about here. Now it's hard to eyeball and to estimate where it is just by looking at the screen. So what we can use is we can use the calc feature that is right above the trace key. So you hit the second button and then you hit trace, and the option we are going to use is number 5, which says intersect. This will make the calculator help us find exactly where they intersect. Alright, now it asks us for the first curve. What they mean by the first curve is the first function, even though our lines are very straight and not curvy. The calculator just uses the word curve to mean function. The first curve, up in the upper left-hand corner of the screen, we see y1 is equal to 2x plus 30, and that is the first one we want to choose. And we want to compare it with where it's going to intersect with our second curve, which is y2 is equal to 6x plus 10. And then I'm going to hit enter. And then it says guess? Question mark. And at this point we can hit enter because there is only one place where these two functions cross. After a moment, it finds the point of intersection. X is equal to 5 and y is equal to 40. So what does this mean? This means that at 5 minutes, both of these calling plans will cost 40 cents. We can interpret this to mean that calling card A, while it is more expensive to use for the first 5 minutes, in the long run it will be less expensive to use if we use it for more than 5 minutes. Calling card B is less expensive for the first 5 minutes, but if we make a long call, which is more than 5 minutes, it will be more expensive.